Right, the inverse trig ratios that we're going to be looking at are the inverse sine, inverse cosine, and the oops. Let me write these in a different way here. Okay, so the inverse sine, the inverse cosine, and the inverse tangent. In each of these cases, the way that they'll kind of be expressed is in this form, because what you do with these inverses is you are finding unknown angles. Okay. Now, when you find unknown sides, you can use Pythagorean theorem, you can use trig ratios, you can use a number of different measures, but when you find unknown angles, you're always going to use the inverse trig ratios. Okay, now, here's the thing that you have to be able to keep in mind, and this is where it ties in the things from the last section, the section on reference angles, okay, is the inverse sine is only defined from negative 90 degrees to 90 degrees. Okay, which quadrants is that?
That would be from
It's quadrant 1 and? It's the theta, the angle. Okay, let's look at our unit circle here. Okay, so we have quadrant 1, 2, 3, and 4. Okay, where is the inverse sine identified? From negative 90, so here's negative 90, to positive 90. So 1 and 4. Those are the quadrants that the inverse sine will give you. Okay, so what about for the inverse cosine? Down to the inverse tangent, because that's the same set. From negative 90 degrees to 90 degrees. So that's, again, quadrants 1 and 4. Okay, and then the inverse cosine is defined for 0 to 180. And again, these are in terms of angles. Okay, when 0 to 180 is which set of quadrants? 1 and 2.
2.
Right, so when you're looking at this, the cosines, or the inverse cosines, will give you values between these two, in these two quadrants. Okay. All right, so if I ask you, or we've talked a little bit about calculating this, using your calculators. If you need to take the inverse sine of 1/2, okay, what is that equal? So again, in terms of degrees, the inverse sine, the inverse keys are here, the green diamonds, and then right next to the sine, cosine, and tangent. So if we took the inverse cosine of 1/2, you get your answer to be 30 degrees. Now, think about what this is saying. What this is saying is if you have a right triangle, remember all of our trig ratios here are based on right triangles, with some angle theta. Theta represents, or the inverse sine tells you that the sine ratio 1/2 is the sine ratio for what angle? Theta. So 1, or sine ratio, is opposite over hypotenuse. So it's asking you which angle has a sine ratio of 1/2. 1/2. And here you should be able to see, if you looked at this, you have a 30, 60, 90 right triangle here. So it makes sense that this would be 30 degrees. If I said, what is the inverse tangent of point 321? I want you to find what is that angle. So that's saying what angle has a ratio of opposite side to adjacent side of 0.321, whatever that number that's written inside here. So if you take green diamond t for inverse tan, 0.321, hit enter, you get approximately 17.8 as your angle measure. Saber? With the calculator. Inverse sine of 1/2.
Do you not have to do solving for that?
No. Because you're just evaluating it.
Aren't you solving for that?
Oh, if you put it like equals x, if you put equals x, you can use solve.
But I did.
Are you in Radian mode?
Yeah.
Okay.
How do you
The right here, how do you know which one you want to be in? Okay, now that is a good question. So how did you know what mode I wanted you in?
Yeah.
What would you do differently if I asked you to find the radian measure for this? Okay, so we put it in radian mode, so we can change our mode. Okay, move it down to radians, which is F2. Oops, I'm sorry. It's down to the angle. Change it to radian. Okay, and then how would I have to enter this if I was asking you for radians? What would I have to do different to enter it? Just switch it to, after I switch it to radians. No. You don't have to do anything. Like I said, Saber asked a good question because how did you know I wanted it in degrees? It's just because I had my calculator in that, and so that's what I asked for. But if we did this calculation, and it'll ask you to find it in both in the homework. Okay, so if we wanted to find what the radian measure was, just hit enter. Okay, make sure you're in radian mode, and now when you hit the solution, you get pi over 6. Does that make sense? Because is pi over 6 equivalent to 30 degrees? Yeah, pi over 6 radians is 30 degrees. So if we looked at the inverse tangent of 0.321, again, and we did our radian measure, 17.8 degrees is going to be equivalent to 0.311, let's say. We round it to 3 radians. So you can find it in either. There's no difference in how you calculate it. The only difference is in what they're asking you to enter it as. Okay, and it will specify that.